Hey Bobcats, this is Mr. Peterson. Today we're going to talk about cubic functions. And your learning goal today should be to be able to graph and transform cubic functions. But before we talk about cubic functions, I want to talk about something else that's near and dear to my heart, and it is cat juggling. I'm serious, people. Don't juggle cats. It's very tragic, very sad. Cat juggling. Don't do it. Onward to the math, though. Um, Cubic functions are functions whose rule contains as their highest degree a variable that's raised to the third power. And we've talked a little bit about cubic functions. You've probably tried them, typing them into your graphing calculator. Here you can see the parent function for cubic functions, x to the third power. And you can see some interesting things. You can see that it crosses at the origin. You can see that it has a domain. Those are all of our x values of all real numbers, and a range of all real numbers as well. And so let's look at some things that we want to do here. First of all, we want to graph the function x cubed, take away 1, and then state the domain and range and the y-intercept. All right, so if we're going to do a cubic function, we need to pick just any number. It doesn't necessarily matter. We want to probably pick some positive and negative numbers to plug in. So let's start off with, well, let's pick some negative numbers to start off with, and you can kind of see something interesting that's going to happen. So let's do negative 2. Well, when we put in negative 2 to the third power, that's negative 2 times negative 2 times negative 2. That would be a negative 8. And then a negative 8 minus 1 more, or in other words, plus a negative 1 would be negative 9. All right, when we plug in a negative 1 into this function, we get negative 1 times negative 1 times negative 1, as we do our exponents first. That's negative 1 minus another 1, or plus another negative 1, so that's negative 2. When we plug in 0 into this function, we get 0 times 0 times 0, which is 0, and then minus 1 is negative 1. When we plug in positive 1 into this function, we get 1 times 1 times 1, that's 1, minus 1 is 0, and let's just go out one more to 2. We get 2 times 2 times 2, that's 8. 8 minus 1 is 7. All right, so let's go ahead and plot some of these. Choose my colors. So many colors here to choose from. Here are my x and y axes. I'm not going to be able to plot all of my points on here, but you're going to kind of get the picture. So let's start with negative 1, negative 2. So we have negative 1, then negative 2. That's one of our points. And then we have 0, negative 1. Ooh, I should have drawn that better. And then we have 1, 0. And then we would have negative 2, 7, which would be right about here-ish. And then we would have negative 2, negative 9, which would be down here-ish, further down a little bit. So you can see here it's kind of a funky looking graph. Not so great because of my poor drawing of it. And then the arrows to show that it goes on infinitely. So our domain, and of course the way that it looks right now, it looks like it kind of has an asymptote here, but it doesn't. We need to remember that we're really zoomed in. If we zoomed out more, we would see that the domain would continue to expand as we add more x values over here and over here. The y would continue to move over. So the domain and the range here would again be all real numbers. And then this time we have a different y-intercept. Our y-intercept is at the point 0, negative 1. All right, transformations are the same as they've always been. If we're going to do a vertical transformation, we want to add out behind the cubing. If we want to do a horizontal translation, we want to take away something that's inside the cubed parentheses. If we want to do a vertical stretch or a compression, we want to multiply by of the whole function by a factor, and if we want to do a horizontal stretch or compression, we want to, inside the parentheses, the thing being cubed, we want to multiply in there. And of course, reflections would be the negative and then the negative inside the parentheses. So describe the transformation of x cubed minus 1, and that's the one we just did. So we're just going to zoom back over here a second. So, well, first of all, there's our parent. Whoa, going too far. There's our parent function. We can see that this, when we did x cubed minus 1, that took us 1 unit down. So, and that would correspond to the vertical translation, which is right there, 1 unit down. And so, yeah. So why don't you guys try this one, and this one, and this one, and this one. And I just realized that those were out of order. So I'm sure somebody's going to point that out to me. Yes, D and E were in the wrong order. But that's life sometimes. I'm not recording the whole video. All right. See you in class.